I've been experimenting with different shapes of impellers for blowers, and I'm pretty sure an impeller with these backwards curved fins like this one are more efficient. And coincidentally, I found another dishwasher in the garbage, and here's the pump from that, and the impeller has very much got backwards curved fins in it, much like this one, although this one's a little bit conical. So now the question is this shape of housing the most efficient? This one here is also kind of spiral shape, so that gives me some confidence. The first question is, how do I cut the airstream here? I've always been leaving a little bit of space because the closer I get to the fins here, the louder this blower becomes. But I figure if I cut the air very close to the impeller, I should force more of it to come out here, which would create more airflow. If I cut it in a non-straight manner, then it's not quite as loud. So let's do some experiments. I made a holder for this anemometer so I can hold it at a consistent position from the inlet, just to get a relative measure of airflow. So we're using 146 watts, and we've got about 11 meters per second right there. And you can hear it getting louder right away. Has not gone up. Power's about the same. So there appears to be no benefit in cutting the airflow. It just makes it louder, but I don't get more airflow going through the blower, and the power consumption doesn't go down. Next, I'll measure if cutting the airstream changes static pressure. So the pressure goes up to about this clamp here, and I've got so the best I can tell is when I stick this thing in there, static pressure is actually going down a little bit. So it looks like there's no benefit in cutting the airstream closer here. Perhaps, if anything, I should be giving it a little bit more room right here because that makes it quieter. For my next experiment, I'll just shift this over a little bit to get more room right here, and we'll see if that makes a difference. So now static pressure is a little bit over 11.5. So we're actually getting a little bit more static pressure with this setup. Airflow is about 10.5, so airflow has gone down a little bit. Power consumption is down by about a watt. So I think what's happening is if I center this in here a little bit more, then we have more air that can spin around and around and around, and just the centrifugal force on the air spinning here will cause a little bit more suction. But having moved it like this, I don't quite get the nice spiral effect, which I think reduces airflow a little bit. So next experiment, let's try it without a housing. But I will need a few blocks just to hold the top cover of my blower. We're now reading 13 meters per second here and 137 watts. So it looks like just letting the air come out on all sides reduces the power consumption and increases the airflow, so that's a big win. And with new housing, static suction is 88 millimeters. So removing the housing means I get better airflow, but compared to having this, I have less static pressure, and I think because I have a housing like that, I get much better swirling of air around here, which adds to the static pressure. Now, a wooden impeller running at high speed with no housing, that could be a bad idea. So for my next experiment, I'll just make the housing a big square box. Static pressure is 10.5. Airflow is 11.9 and 145 watts. Let's take out a little bit more of the housing. Now we've got 12 at 142. So the airflow with a three-sided box is still better than I have with this part. And it could be fairly safe because I can make sure that if the impeller were to explode, this is a fairly safe direction for it to go. But static pressure is still less than I get with this. And static pressure is actually quite important because in a dust collector, a lot of times most of the airflow is blocked from hoses and filters. Well, given that there's no benefit in cutting the airstream close here, for my next experiment I'm going to try to bend this enclosure open a little bit, which makes for a bigger outlet and more room around the impeller. 11.5 meters per second, 145 watts. Maybe more like 11.3 average. Now I've just rerun all my static pressure tests with this plate here, which lets through a limited amount of air, and presumably the more pressure I have here, the more air is actually also going through here, because for a dust collector with the filters and hoses and air going through the tool, airflow is typically greatly restricted. And with that, the spiral housing, initial and open up a bit, had more pressure than I did with no housing or rectangular housing. So for a dust collection scenario, the spiral housing is still beneficial versus a rectangular housing, even though the rectangular housing will have more airflow if there's no restriction to it. Now, just to illustrate how much airflow is restricted in a dust collector, I've got my anemometer hooked up near the outlet of the blower here, and let's run it when I disconnect the hose and the Cyclone. So the hose is not hooked up to anything. Let's turn it on. So right now this is reading 7.7 meters per second. Let's take the hose off. And now we're up considerably at 10.2. The Cyclone has a lot of air resistance, so let's disconnect the Cyclone. And now we're at 30 meters per second. So that tells me the Cyclone makes for more air resistance than sucking the air through these 4 small holes. So you're probably thinking, well, I have too much constriction inside the Cyclone, but if you look in here, I've got a big opening here, and the inlet is also quite large. The problem with the Cyclone is the air spins around so much, and it's got so much centrifugal force forcing the air and the dust outwards that it causes a lot of back pressure. It's like sucking air through a blower in reverse. Now, just to illustrate this, I'm going to put some junk inside the Cyclone, which intuitively you would think will restrict airflow even more. And now airflow is almost twice as what it was with just a Cyclone because I prevented the air from spinning. But the Cyclone isn't the only thing that restricts airflow. So now let's just have the hose and no Cyclone. And airflow now is actually less than with just a Cyclone. So this hose has got more air resistance than the Cyclone. So I hope this demo with my homemade dust collector helps you understand how static pressure really dominates the system. Because by the time you've sucked the air through hoses and Cyclones and filters and through the machine itself, the CFM rating of your dust collector blower really doesn't matter. It's how much pressure you can get that actually determines how much air you're going to suck through the whole system.